Gießerei is renowned for its ability to produce exceptionally large and complex castings, including hand-formed spheroidal graphite cast iron castings weighing up to 320 tons. This impressive feat has earned them a world record. Spheroidal graphite cast iron, also known as ductile iron, is chosen for its excellent mechanical properties including high strength, toughness, and ductility. The spheroidal nodular graphite structure enhances these properties compared to traditional flake graphite cast iron. The production involves melting iron at high temperatures, around 1,350 degrees Celsius, and pouring it into molds. For the 320-ton casting, Simplecamp used 5 ladles of molten iron. The process requires precise control to ensure uniformity and prevent defects. Given the size and complexity of these castings, hand molding is often employed. Skilled craftsmen use specialized tools to shape sand into the desired mold cavity. Cores, which form the internal cavities of the casting, are also created using similar techniques. The necessary spheroidal graphite cast iron is melted in large furnaces, ensuring precise chemical composition and temperature control. The molten iron is carefully poured into the prepared mold, filling every crevice and ensuring a uniform casting. The casting is allowed to cool gradually under controlled conditions to prevent cracking or distortion. As the iron cools, it solidifies, forming the desired shape with the characteristic spheroidal graphite microstructure. Once solidified, the casting is carefully removed from the mold. Depending on the specific requirements, the casting may undergo machining processes to achieve precise dimensions and tolerances. Rigorous quality control measures are implemented to ensure that the casting meets the specified standards for strength, hardness, and other properties. These large castings are used in heavy machinery and industrial applications, such as the lower press beam for a 12,500-ton closed-die forging press. Such components are critical for industries requiring high-strength and durable materials. Simplecamp's achievement of casting a 320-ton component set a world record, showcasing their expertise and capability in handling large-scale projects. Producing castings of this magnitude presents several unique challenges. Maintaining the stability of the large, hand-formed molds during pouring and cooling is crucial. Ensuring consistent temperature control throughout the casting process is essential for achieving the desired material properties. Safely handling and transporting these massive castings requires specialized equipment and expertise. Large castings, such as those produced by Simplecamp Gießerei, are utilized in several industries due to their strength, durability, and ability to be customized for specific applications. There are some key industries that rely on large castings. 1. Power generation. Large castings are essential in the construction of turbines, generators, and other components for power plants, including nuclear, hydroelectric, and thermal power stations. 2. Mining and earth moving. Heavy machinery used in mining and earth moving, such as excavators, bulldozers, and dump trucks, often incorporate large castings for critical structural components. 3. Marine and offshore. The shipbuilding industry uses large castings for parts like engine blocks, propellers, and structural components of ships and offshore platforms. 4. Oil and gas. Equipment used in the extraction, processing, and transportation of oil and gas, such as drilling rigs, pumps, and compressors, often includes large castings. 5. Construction. Large castings are used in the construction of bridges, buildings, and infrastructure projects, providing the necessary strength and stability for these structures. 6. Aerospace. The aerospace industry uses large castings for components in aircraft and spacecraft, including engine parts and structural elements. 7. Heavy machinery. Industries that manufacture heavy machinery for various applications, such as steel mills, paper mills, and cement plants, rely on large castings for their equipment. These industries benefit from the robustness and versatility of large castings, which can be tailored to meet specific requirements and withstand demanding operational conditions. Transporting and installing large castings involves several specialized steps to ensure safety and precision. Before transportation, the casting is carefully inspected and prepared. This includes cleaning, applying protective coatings, and securing any loose parts. Heavy-duty cranes and lifting equipment are used to load the casting onto transport vehicles. This process requires precise handling to avoid damaging the casting. Specialized transport vehicles, such as multi-axle trailers or self-propelled modular transporters, SPMTs, are used to carry the heavy load. These vehicles are designed to distribute the weight evenly and navigate through various terrains. Detailed route planning is essential to ensure the casting can be transported safely. This includes checking for weight restrictions on roads, bridges, and tunnels, and obtaining necessary permits. The transport is often accompanied by escort vehicles and monitored throughout the journey to ensure safety and address any issues that may arise. The installation site is prepared in advance, including creating a stable foundation and ensuring all necessary equipment and personnel are ready. Once the casting arrives at the site, it is carefully positioned using cranes and other lifting equipment. This step requires precise alignment to ensure the casting fits correctly into its designated place. The casting is then secured in place using bolts, welds, or other fastening methods. This ensures the casting remains stable and can withstand operational stresses. The casting is integrated with other components and systems. This may involve connecting it to machinery, piping, or electrical systems, depending on its application. After installation, the casting and its connections are thoroughly tested and inspected to ensure everything is functioning correctly and meets safety standards. These steps require careful planning, coordination, and the use of specialized equipment to handle the size and weight of the castings. Texmo Blank manufactures long lifespan steel, aluminum, cobalt, and nickel-based precision castings in air and vacuum at modern factories in North America, Europe, and Asia. They are known for solving complex manufacturing challenges, industry-leading turnaround times, and our stringent in-house quality control. Let's dive into the details of investment casting, its processes, and specific applications, including those by FEINGUSS Blank. Investment casting, also known as lost wax casting, is a precision casting process used to create intricate and complex metal parts with high dimensional accuracy and fine surface finishes. This method has been used for thousands of years and is valued for its ability to produce components with accuracy, repeatability, versatility, and integrity in a variety of metals and high-performance alloys. A wax model is created using a mold or 3D printing. The wax model is typically attached to a wax tree for support during the subsequent steps. The wax tree is dipped into a slurry of refractory ceramic material. This slurry coats the wax model, forming a thin ceramic shell around it. This process is often repeated several times to create a sufficiently thick ceramic shell. The ceramic shell is heated to melt and remove the wax, leaving a hollow cavity in the shape of the desired metal part. Molten metal is poured into the ceramic mold. The metal fills the cavity, solidifying into the desired shape. Once the metal has cooled, the ceramic shell is broken away to reveal the finished casting. The casting may require additional finishing processes such as machining, grinding, or polishing to achieve the desired surface finish and tolerances. Investment casting is used in a wide range of industries, including aerospace, turbine blades, engine components and aircraft parts, automotive, engine components, transmission parts, and brake systems. Medical, dental implants, surgical instruments, and medical devices. Jewelry, rings, necklaces, and other intricate jewelry pieces. Industrial, pump components, valves, and gears. Investment casting offers several advantages that make it a preferred method for producing complex and high-precision metal parts. Investment casting can produce highly intricate parts with complex internal geometries that are difficult or impossible to achieve with other processes. This method delivers a smooth surface finish, minimizing the need for additional post-processing or machining, which can reduce production time and cost. Investment casting achieves tight tolerances, ensuring accuracy and consistency across all parts. This is particularly useful in industries like aerospace, where precision is critical. The process is highly versatile and can be used with a variety of materials, including various metals and alloys. Investment casting produces minimal waste, making it a cost-effective solution for diverse manufacturing needs. It is scalable, allowing for the production of both small and large batches, making it useful for both prototyping and high-volume production. These advantages make investment casting an ideal choice for industries requiring detailed and precise components, such as aerospace, automotive, medical devices, and jewelry. While investment casting offers many advantages, it also has some limitations and challenges. The process can be expensive, especially for small production runs. The cost of creating the wax patterns and ceramic molds can add up, making it less economical for low-volume production. Investment casting involves multiple steps, including creating wax patterns, building ceramic shells, and removing the wax. This can result in longer production times compared to other casting methods. There are constraints on the size of the parts that can be produced. Large parts may be difficult to cast due to the limitations of the ceramic molds and the handling of molten metal. Ensuring the quality of the final product can be challenging due to the many variables involved in the process. This requires stringent quality control measures. Casting parts with intricate internal cavities can be challenging. The process may not be suitable for parts requiring deep or small diameter holes. While investment casting is versatile, not all materials are suitable for this process. Some metals and alloys may not perform well or may be difficult to cast. Despite these challenges, investment casting remains a valuable method for producing high-precision and complex parts, especially when the benefits outweigh the limitations. Walzen IRLE GmbH is a renowned manufacturer with nearly 200 years of experience in producing high-tech cast products, including rolls, pistons, and wear-resistant castings. Walzen IRLE specializes in the production of various types of rolls used in different industries, their rolls are known for their durability and high performance. High-quality raw materials are melted and cast into molds to form the basic shape of the rolls. The cast rolls undergo heat treatment to enhance their mechanical properties, such as hardness and strength. Precision machining processes are used to achieve the desired dimensions and surface finish. Each roll is subjected to rigorous quality control tests to ensure it meets the required standards. Meanwhile, the production of pistons at Walzen involves several key steps. High-grade materials are chosen based on the specific requirements of the pistons. The selected materials are cast or forged into the basic piston shape. Advanced machining techniques are used to achieve the precise dimensions and tolerances required for pistons. Various surface treatments, such as coating or nitriding, are applied to enhance the wear resistance and performance of the pistons. Each piston undergoes thorough inspection to ensure it meets the stringent quality standards. Walzen also produces wear-resistant castings for industries where wear is a significant concern, such as the cement, power plant, and dredging industries. They sources premium materials, such as cast iron, steel, and other alloys, ensuring that their products meet the highest standards of quality. The foundry team carefully prepares molds, ensuring that they are accurate and free from defects. These methods allow them to produce a wide range of components with varying sizes and shapes. After casting, the components undergo precise machining processes to achieve the desired tolerances and surface finishes. This may involve turning, milling, drilling, and grinding. To enhance the mechanical properties of their products, Walzen performs various heat treatment processes, such as annealing, hardening, and tempering. This ensures that the components have the necessary strength, hardness, and toughness for their intended applications. Throughout the production process, rigorous quality control measures are implemented to ensure that the products meet the highest standards. This includes inspections, testing, and documentation. Walzen IRLE's commitment to continuous research and development, along with their close cooperation with machine builders and plant operators, has made them a leader in the industry. Their products are designed to minimize wear-related costs and optimize the lifetime of components.